Hello all, welcome to the class. In today's class, we'll understand what is meant by conditional or implication connectives. Let us consider any two statements. P and Q. The statement P and Q can be written using implication or conditional connectives with the keyword called if, then between P and Q. If beginning of the P, then keyword between P and Q. So how do we write this? A right arrow is used for conditional or implication. P is called the hypothesis, Q is called the conclusion here. P is a given hypothesis, Q is a conclusion. So this truth table has a truth value of a conditional, a 0 in case of the hypothesis is true and conclusion is false, then such statement is a false statement. Rest all are true statements. As an illustration, let us consider the following propositions. P is 2 is a prime number, Q is 3 is a prime number, R is 6 is a perfect square, S is 9 is a multiple of 6. P and Q are true propositions, R and S are false proposition here. We write the first one. I will show first one how to write. If P, then Q. In the similar way you have to write for all, and also you can look into the values. If this is the condition, then result becomes 0, otherwise it is true. By implication, biconditional, it is also called as biconditional. If we write the word called if and only if, P if and only if Q is called as biconditional of P and Q. Notation used is both direction arrows. Means if P then Q and if Q then P. The meaning of if and only if, in both the direction you have a conditional, P conditional Q and Q conditional P. That is what biconditional. So you have to write what is PQ and find out P conditional Q, find out Q conditional P, then do and between both. So 1 and 1 is 1, 1 0 is 1 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1. Example, you can take the same old example and start writing if and only if, keyword between two proposition. Now this is a summary of all previous. So summary of all the connectives are tabulated here. Just to compare between two values, look at this. These two are negation to each other, opposite to each other. If it is 1, it's changing to 0. If it is 0, it's changing to 1. So that completes proposition and basic connectives. Moving on to a problem. Let P, Q, R are three statements. You have to express this in terms of compound proposition in the words. So following are compound propositions. You need to write this compound proposition by substituting its equivalent statement. I'll show the first one. Rest you can try yourself. P and negation Q. So what is P? P is nothing but a circle is conic, and because you have an and keyword, and negation Q. What is negation Q? Negation Q becomes square root of 5 is not a real number. It's not real number. That you have to write here. Square root of 5 is not a real number. The similar way you have to try for all this. Appropriate keywords to be used for all these connectives, compound prepositions. You can just replace that value in the appropriate place. Try yourself. Moving on to next problem. Construct the truth tables for the following compound preposition. So when you construct the truth table for this, you have to write PQ first, then negation Q, because I need negation here for my computation, then given compound preposition. Find this value. We know the value how to give for this table: 0 1 1 0 1 1. Since there are two proportions here and each one is having truth value 2, so how many rows are required? 2 to the power of 2. If there are 3 proportions PQR, then 2 to the power of 3, that is totally 8 rows or combination of values are there. Okay, here only 4. 2 to the power of 2 is 4 values. Negation Q becomes 1 1, sorry, 0 here, 1 here, 0 here. Now I have to make an entry here by applying AND between these two. 0 and 1 becomes 0 because as per the connectivity conjunction. 0 and 0, the first, sorry, 0 and 1, okay, this value. Next 0 and 0, 0 and 0 becomes 0. Next 1 and 0, 1 and 1, sorry, the values you should take is these two columns. 1 and 1 becomes 1, 1 and 0 becomes 0. This is what a value you are going to get. In the similar way you have to try for all this in the table. Do yourself.